How are you all, guys? Hope you are all doing well. Audio both are clear? Yes, Babu all rounder. Yes, I'll be sharing that one. Don't worry, I'll be sharing the PDF once the class gets over. Right? I'll be sharing it. Don't worry. Right. All formula revision of this highway engineering by myself, Rajendra Prasad. Right. So here, all of you, welcome to Unacademy. Let's crack it. Right? Everyone, get ready to crack. All of you. Right. So this is my profile, you can follow me at which, and this is the referral code you have to use. RP Civil Live is the referral code you have to use always whenever you are subscribing for the Plus and Iconic courses. Right. So these are all the Plus courses I'll be taking in Unacademy Plus platform. And whenever you are taking this Iconic subscription, these are all the benefits you can say, right? Personal coach will be available, personalized test series and study planner with bi-weekly reviews. You'll be having all these things, right? And a very important one, those who are attending for the GATE examination, GATE 2022 paper analysis will be happening. So here which one? 5th CSIT and Triple E, and 6th February EC and chemical, and 12th February civil, and 13th February mechanical, right? So for these people, these are the GATE paper analysis on Unacademy, you can find out, yes, na? And if you just observe, there is an exciting offer February 3rd to that February 6th only this offer is valid, right? February 3rd to February 6th only this offer is valid, right? What is a super combo offer, you can say, right? Whenever you are taking this 2 years plus subscription, you will be getting this 1 year placement assistance. 1 year plus subscription, if you are taking that 6 months placement assistance, you will be getting, if you just observe it like that, is not? So in this placement assistance, these are all the benefits, additional benefits you will be getting if you just say, is not? Now, so these are all the things you will be learning in this placement assistance, you can say, right? These are all the concepts you will be learning, right? You can say. Don't miss these, all of you, right? So now coming to this, there is a scholarship test you will be having on which one? On 6th February at 11 AM you will be having 20 questions will be there, and 60 minutes, 20 questions with 60 minutes time will be given, and you will be having this 4 crore worth prizes you can win, right? Means not single person can win 4 crores all together, okay? So ranks 1 2 3 100% free plus subscription, 4 to 10 75% discount, 75% discount, 11 to 50 50% discount, and 51 to 100 25% discount in the plus subscription you are having, okay? Right. So now these are all the new batches starting, you can see if you just observe. These are all which one? These are new batches starting if you just observe, right? Now, so these are all the plus courses going on by me, right? These are all the free courses done by me, right? Now coming to this all formula revision of this highway engineering, right? Today will be the last class on this all formula revision. So there is no extension of these classes beyond this. So today will be the last class, you can say. And in the last class, what we have discussed, if you just remember, all of you, which part we have discussed, all of you? Which part we have discussed in the last class? That signal design part we have discussed, na? Yes or no? That signal design part we have discussed, that 323 formula number, right? Yes, na? 323. So this is your what is that, you can say, that flow expected, right? Flow expected we have said, right? Possible flow or capacity, right? 323. And now we'll be continuing our discussion on that, and we'll be completing the remaining parts also. 323 means this is your 324. So what is that? 324, you can say if you just observe. So here design of signal means design of all times, na? So minimum amber time. What is that minimum amber time you are having? If you just observe that A minimum will be equal to, so whenever you are having this intersection, right? Whenever you are having this intersection, green color is there means it tells that you are you can move. Red color means you have to stop. Amber color means what is it telling? It is giving the warning, na, that if possible, if time is sufficient, you can stop your vehicle sufficiently. If time is not sufficient, you can cross the intersection, right? Let us say this is your width of this intersection, and when you can say your vehicle is crossing the intersection, whenever your vehicle comes up to this point, you can say that this has crossed the intersection, right? What is the minimum amber time, you can say? That a minimum amber time is equal to that SSD it has to travel a distance of this SSD to stop, right? SSD divided by this speed, for which purpose? To stop the vehicle. If you wanted to stop the vehicle, this much, right? And if you wanted to cross during amber time, you need not stop always, you can cross the intersection also, right? If you wanted to cross the intersection, what is the distance you have to travel? SSD plus this W plus this L divided by this speed, right? For which purpose you can say this is for which purpose? This is to cross the intersection, you can write like that, yes, na? Right. So there is a minimum time required to cross the intersection, right? Like that. So SSD plus W plus L by V, right? Now if you just observe it, what is that you can say? Intergreen, right? What is that you can say? Intergreen, right? Intergreen, right? Intergreen or yeah, sorry, intersection clearance time. If you just observe, what is that intersection clearance time? If you just say, intersection clearance time, which one? Intersection clearance time, how much it comes to be? If you just observe it, that intersection clearance time is nothing but your time required to cross the intersection, right? Can we say that same? SSD plus this W plus this L divided by this speed V. Yes, intersection clearance time is this one, right? And for pedestrians, what is it? Pedestrian crossing time, you can say, if you just observe, whenever these pedestrians are crossing this road, what is the pedestrian crossing time? If you just observe, pedestrian crossing time, that a TP, you can say, right? It is equal to which one? How much you can say? That width of this road W divided by this velocity of this pedestrians, right? What is the velocity of this pedestrians we have to take if nothing is mentioned? It is taken as your 1.2 meter per second as per IRC if nothing is mentioned, right? The pedestrian walking speed we have to take it as which one? This 1.2 meter per second, right? 1.2 meter per second, right? Like that, isn't it? 1.2 meter per second is the pedestrian walking time we have to consider if we just observe, right? Like that, yes, na? So that is for intersection clearance time for vehicles. This is for vehicles and the bottom one is for pedestrians, you can say, right? Like that. Now that is the time required, 3:26. What is the time available, you can say? Intergreen. What is the meaning of this intergreen? Intergreen, the name itself is telling that it is a time gap between the two successive greens, right? So can we say it is a time between, it is a time gap between any two adjacent greens, right? They need not be corresponding to same phase, right? Time gap between any two adjacent greens, or you can also say ending of this one green to starting of this next green, or you can also say it as it is the time available, it is a time available for which one? This is crossing the intersection. It is a time available for which one? This is crossing the intersection, right? Time available for crossing the intersection, you can say if you just observe, right? Like that. So now for pedestrians to cross 3:27, right? For a pedestrian to cross, what is the condition? Or for vehicles to cross? For vehicles to cross, what is the condition satisfied if you just observe? That intergreen must be, time available should be greater than or equal to which one? This time required, na? What is the time required? SSD plus this W plus this L divided by this velocity, right? So what is that? For this condition, what is that? Time available should be greater than which one? This time required, yes, na? Time available should be greater than which one? This time required, then only you can cross, right? What is that intergreen here if you just observe that? But what is that intergreen if you just observe? That intergreen will be equal to, right? Hi Lina. Intergreen will be equal to which one? This amber time, right? Intergreen for this ith phase is equal to amber time for this ith phase plus this all red time, right? Amber time for this ith phase plus this all red time, right? That is your intergreen, you can see if you just observe it like that, isn't it? So there are questions on this concept also, right? Previous questions on this concept also you can see, right? Whenever this intergreen, right? Yes, I am good, how are you? Whenever this intergreen or time available is greater than or equal to that time required, then only that fellow can cross the intersection, right? Otherwise, can you expect this vehicle fellow to cross the intersection, or he cannot cross? Then otherwise this vehicle fellow cannot cross the intersection if you just observe it like that, isn't it? It's not? No. Right. So that is what you are having, right? That is what you are having, right? Now tell me, what is the green time for this pedestrian crossing? whenever you consider this green time for pedestrian crossing. What is the green time for this pedestrian crossing? If you just observe that GP, green time for this pedestrian crossing is equal to that what is that TS startup last time plus crossing time, right? Yes, no, crossing time, right? Crossing time is nothing but your width of this intersection or road divided by this velocity of this pedestrian, right? Velocity of the pedestrian, how much we have to take? Just now I have mentioned 1.2 meter per second is the velocity of the pedestrian. We have to take it now. Yes, absolutely, right? So what is it? You can say that a TS will be your start up last time or waiting time, you can say, right? Or a walking time, you can say. What is it? Start up last time, if you just observe that start up last time or walking time, you can say, right? How much it will be taken? It is taken as your 4.7 seconds, right? That TS will be taken as your 4.7 seconds as per this IRC, right? It will be taken as your 4.7 seconds as per IRC, you can say, if you just observe. Yes, not right. Now, so here, what is it you are having again? 329. So whenever you are providing this signal, there must be delays you will be having definitely. Na? So there are two delay models we are having. What is the first one? You can say that basic delay model, right? Or before going to that, right? What is it a cycle length we can give if you just observe? What is the cycle length you can give? Effective red, right? What is the effective green? You can say first of all, effective green. Effective green small g is nothing but small g for the scythe phase is equal to actual green for the scythe phase plus this actual amber for the scythe phase, time provided minus time not utilized. So effective green is actual time utilized, right? What is that? Actual green plus this actual amber minus this startup last time minus this clearance last time, right? What is the TSL you can say? TSL is nothing but your startup last time. Startup last time, right? What is it? TCL you can say it is nothing but your clearance last time, right? It is nothing but your clearance last time if you just observe, is not? So that is your effective green, right? So in the previous class we have mentioned effective green ratio is nothing but your effective green time divided by which one? This effective green time divided by which one? This cycle length is called as your effective green ratio, no? Is not? Obviously, right? Startup last time, right? Now tell me what is that effective red if you just observe? R is normally red. What is the effective red? Effective red, we are giving the symbol R dash, right? R dash is equal to which one? All of you? Effective red is equal to which one? This R red, actual red for the scythe phase plus what is it you can say? Plus what is it you can say? Plus this startup last time plus this clearance last time, right? When you are adding this startup last time, clearance last time to this, it will become effective red, right? Effective red is the time which is not actually utilized. Anyway, that red, original red will not be utilized fully for movement of vehicles because we are stopping the vehicles. But the startup last time and clearance last time also vehicles will not be moving, not utilizing. So therefore, if you just add these two, what is it you are getting? Effective green and effective red. If you add G plus A minus TSL minus TCL, so plus R TSL TCL will get cancelled. Right? What is it you are getting? Cycle length, right? What is it? A cycle length if you just observe? That is cycle length C equal to, right, the C naught or C will be equal to actual green plus actual amber plus what is it you can say that actual red, or you can also write it as which one? This effective green for this ith phase plus which one? This effective red for this ith phase, right? Effective green plus this effective red also, right? If you are adding these two also, TSL cancel, TCL cancel, so green plus amber plus red you are having, right? Like that, isn't it? So this is your cycle length, you can say, yes, na? So like that. Now we'll be moving on to this. So what is the next one? You can say that 331 wala. It is what is it? You can say basic delay model. So what is that basic delay model? If you just observe, whenever your vehicles are approaching the intersection, if you just observe it, this is your intersection, let us say. Whenever your vehicles are approaching the intersection, what happens? First vehicle will come here first. After some time, second vehicle will come. Yes, na? After some time, this third vehicle will come, right? Like that, each and every vehicle will come one after the other, na? When one vehicle comes, after some time, second vehicle comes, after some time, third vehicle comes, after some time, fourth vehicle comes. when one after the other these vehicles are approaching the intersection, right? So now approaching the intersection, right? What is it you can say? What is it you can say? Then what is it you can say? You can have this changes required definitely or not? Yes, right? So we'll be having this arrival of these vehicles, and there will be a departure of these vehicles, right? Whenever there is a departure of these vehicles also, what happens? Whenever you are having this departure of these vehicles also, first vehicle will leave first, and after the second vehicle will leave. So if you just observe this delay curve, right, that curve, if you just observe arrival departure curve, what is that arrival departure curve you can say? This is your arrival departure curve you can say. Right. So if you just observe this, right, I'll be using some other color for representing it. I'll be using which one? This green you can say. So here what is that? First vehicle will arise, right? So what is that? This x-axis, what is it you can say? X-axis, it will be your time, and y-axis, what is it you can say? That y-axis, it will be this q length, right? What is the meaning of this q length? It is the vehicle number you can say, vehicle number you can say, like that, is not? So now let us say this is your nth vehicle arriving at this place, isn't it? So like that, if you just consider this portion, right, what is it you are having? So during this vehicle, right, during this time, first vehicle will be completely waiting, na? So completely it is not utilized. Means can we say it is your effective rate? Yes, but this time if you just observe, during this time all vehicles are leaving, na? During this small portion of time all vehicles are leaving the intersection, right? This is your departure curve you can say. And what is this curve if you just observe? That is your arrival curve, na? This is your arrival curve if you just observe. Oh, sorry, not arrival, arrival. It is your arrival curve. This is your arrival curve, right? Like that, is not? So last vehicle, by the time last vehicle comes into the intersection, what will happen? That entire red will become zero, na? So by the time last vehicle is approaching the intersection, that red will be converted to green. It will just come and go, right? There is no delay. So here, what is that? This is your effective green time you are having, right? Effective green time you are having for the ith phase. And what is this total? You can say this total comes to be this cycle length C naught, na? Yes, this total comes to be which one? This is cycle length C naught. You can say, if you just observe, right, like that, isn't it? Now what is the delay for this first vehicle? This much is the effective red is the delay for first vehicle, na? What is the delay for this last vehicle? It is a 0, because the time gap between the arrival and departure activities is called as your delay, right? So now because it is linear relation, what is that average delay per vehicle you can say according to this model, basic delay model? There was a previous question in this GATE from this also. What is that average delay model? Average delay model, average delay per vehicle, right? It is your basic delay model. In this basic delay model, right, what is that average delay per vehicle you are having? Average delay per vehicle. How can you get this average delay per vehicle? If you just observe that di will be equal to first vehicle 0 plus second vehicle Ri divided by 2, right? So means simply this is your effective rate for this ith phase divided by 2, right? Like that. Average delay per vehicle, right? Average of this first and last values is equal to average of all the values, because it is a linear variation you are having, right? Like that. It's not right. So this is what you are having, right? Simply that effective rate divided by this 2, right? Simply that effective rate divided by this 2, right? Like that you can say. Yes, now? Now, what is that? But practically will it happen like that? But practically, yes, Atul, your formula is correct. But that is correct for which one? This Webster's delay model. The next one it will be correct, okay? For the next one it will be correct, you can say, okay? I'll just write that formula also, Atul, don't worry. This is for the basic delay model, right? But what happens whenever some vehicles are moving from this first intersection to this second intersection? Only one vehicle after that they will move, or some vehicles together they will be moving generally? Some vehicles together they will be moving generally, na? Some vehicles together they will be moving generally. So whenever some vehicles are moving together, means arrival time of all the vehicles will be same, departure time of these vehicles will be same. So that is how this Webster has given that delay model, right? What is that you can say? That Webster's modified delay model, right? Webster is a fellow. Webster's delay model you are having. So what is the Webster's delay model? You can see in this Webster's delay model you will be having like this, right? You will be having which one? This like this, in this manner. What is it? You can say first some vehicles are arriving at this place. No? Some vehicles will be arriving at a time. All vehicles together, right? This number of vehicles, and after some time what happens? This one vehicle after the other, one vehicle after the other will come, and this is the departure curve. You can say this is the departure curve, right? Whatever the vehicles, let us say some 5-6 number of vehicles, right? This is your Q length. This is your Q length if you just observe. And what is this? This is your time. No? And what is this curve if you just observe? That is your arrival curve. And this is which curve you can say? This is your departure curve, you can say, right? That is your arrival curve, and this is your departure curve if you just observe, right? Like that. And now what is it you are having? This is your all red, right? This is your all red, you can say, for this ith phase. And what is happening during this time? What happens in the first 5-6 number of vehicles, right? 5-6 number of vehicles or 10 vehicles, they will be moving at a time, right? They will be reaching the intersection at a time, they will be leaving also at a time, right? So what is happening then during this time, right? During this second time, all vehicles are leaving. All vehicles are leaving means it is your which one? This effective green time, you can say. All vehicles are in motion, all vehicles are utilizing for motion means, can we say it is effective green? Yes, it is absolutely right. And from here to here, what is that? You can say this is your cycle length C naught, right? Now can we say average delay will be equal to, so delay for this first some number of vehicles will be same, last vehicle is 0. So can we write that average delay as effective rate plus this 0/2? No, we cannot write it, right? No, we cannot write it, right? Then how can you get that if you just observe for this average delay per vehicle? It is average delay per vehicle, right? What is the average delay per vehicle? That di is equal to C naught by this 2, right? What is that C naught? Cycle length into 1 minus which one? This effective green for the ith phase divided by this cycle length, means effective green ratio, right? Whole square, right? Divided by how much? You can say that 1 minus this Qi by this Si, right? What is the Qi by this Si? Normal flow or design flow divided by this saturation flow, right? This is how we have to get this which one? Average delay per vehicle, right? This many seconds per vehicle. Now what is the generalized formula you can use, or we can use this formula also, right? What is that average delay per vehicle, you can say, right? Yes, Suhel, good evening, how are you? Right. How is your preparation going on? Right. So this is your di, right? This is your di. What is the di? You can say there is one thing called as your area of this triangle. Area of this triangle or shaded portion, right? Okay. Area of this triangle. Thank you. Area of a triangle or shaded portion. Because right, area of this triangle or shaded portion. Okay, area of this triangular shaded portion divided by which one? This number of vehicles or Q length, right? Number of vehicles or Q length, you can say, right? Number of vehicles, you can say, is not number of vehicles or Q length, right? Whatever it is, right? So how can you get this shaded portion or triangle? Because whatever the data given, whatever the curve given, you can convert this curve into this format, right? How can you convert this curve? You can convert this curve into, right? Either you can convert that curve also, right? Same. You can convert, right? You can convert this curve into this format, right? You can convert this curve into this format, right? Which format you can convert if you just observe? This format, right? This is a format, right? Let us say you will be having this shaded portion or this triangle, right? Any curve, any variation is given, any arrival departure curve can be converted into this format, you can say, if you just observe. Yes, no? So in this, what we need to do here, if you just observe, what is that you can say here? So this is how you are having, right? One second, let me just draw this in a different manner, right? So this is how you are having it. This is how you are having, actually this is your triangular portion you'll be having, na? This is your triangular portion you'll be having, right? And now what are these values if you just say? What are these values if you just say, right? From here to here it will be your cycle length, na? So this is your, from here to here it will be your cycle length, you can say. From here to here it will be your which one? This is cycle length if you just observe. It's not cycle length C naught, right? And what is this one if you just observe? This is your effective rate, you can say, right? This is which time you can say that effective rate Ri or R dash, right? And what is this time? You can say this is your effective green time, GI, you can say, right? GI, effective green time, right? Yes, now. So this is your normal flow VI value, and this is your saturation flow SA value, right? So area of this shaded portion, if you are getting the area of this shaded portion divided by this Q length, right? That also will give which one? You can say, right? How it has come? This is your time, and this is your cumulative number of vehicles, right? Cumulative number of what? Vehicles. From this you will be getting this, right? From this you will be getting the curve, you can say, right? The area of this triangular shaded portion divided by which one? This number of vehicle arrivals, right? Number of vehicle arrivals or Q length, whatever it is, right? Like that. This is your 331. Now, if you just observe it, what is it? You can say that probability. What is it? You can say that probability. There are questions on this probability also. Probability of which one? Probability of arrival of what? Probability of arrival of n vehicles, right? N vehicles. Probability of arrival of n vehicles with the time headway. N vehicles with which one? N vehicles with the time headway. Probability of arrival of n vehicles with the time headway. What is the time headway? Lesser than or equal to t seconds, right? So what is that? You can say that probability of arrival of this n vehicles, right? P n vehicles with the time headway lesser than or equal to 2 seconds, right? What is that given? If you just observe, that is nothing but your lambda t power n, right? N number of vehicles na into e power minus lambda t divided by this n factorial, right? What is it? Lambda, you can say, if you just observe, lambda is your mean rate of arrival na. Lambda is nothing but your mean rate of arrival, you can see, if you just observe, mean rate of this arrival, right? So this is your probability of arrival of n vehicles with time headway lesser than or equal to t seconds, right? Same that probability of which one? This probability of which one? All vehicles. Probability of all vehicles with that a time headway greater than or equal to greater than t seconds, right? Not greater than or equal to, it is greater than t seconds, right? All vehicles to have greater than t seconds means, can we say it is 0 vehicles with lesser than t? So we'll be using the same thing, right? We'll be using the same thing, right? What is it? You can say that p 0 comma which one? That p 0 comma that time headway lesser than or equal to t, which is equal to p probability of which one? This all vehicles with the time headway greater than t seconds, right? Both are same, right? Both are same, right? How can you get this? So here 0 n factorial lambda t power 0 means something power 0 is 1, n factorial 0 factorial is 1, so simply what is it you are having? E power minus lambda t, that's it. Yes, na? And probability of which one? This all vehicles with which one? This time headway is in between what? All vehicles with which condition? If you just all of you, all vehicles with which condition? Time headway is in between two values, right? When the time headway is in between these two values, right? T1 lesser than this, lesser than or equal to that TH lesser than or equal to that T2. How can you get this? That probability of which one? This all vehicles with what? That T1 lesser than or equal to that time headway lesser than or equal to T2 seconds, right? Probability of time headway between all vehicles to have time headway between this T1 and T2, right? So e power minus lambda T1 minus e power minus this lambda T2, right? That is what you are having if you just observe it like that. Is it clear, everyone? Yes, na? So this is what the probability curve probability you are having, right? Based on this is which one? This is based on which one? This Poisson's or negative exponential Poisson's effect or negative exponential effect, you can say. Poisson's effect or negative exponential effect, you can say, right? So generally we are considering this Poisson's effect or negative exponential effect only mostly, right? Like that. Yes, na? 332. Now this is your 333. Now what is that? You can say that fundamental diagram. How can you get this fundamental diagram? The relation between this QKV, right? What is the fundamental relation? Q equal to KV is the fundamental relation. Now the relation between this QK and V, if it is drawn in the diagrammatic format, right? If it is drawn in the diagrammatic format, then you can say, right? Then you can say it is which one? This fundamental diagram, right? The diagrammatic format representation between the fundamental parameters is called as your fundamental diagram, you can say, right? Like that. So what are the different models you are having? If you just observe, What are the different models you are having for representing this fundamental diagram? So these are your macroscopic models you are having. These are your macroscopic models you are having, and one regime or single regime models, right? What is the meaning of this single regime? Same variation throughout, right? Macroscopic you can say two or multi regime, you can say, if you just observe two or which one, this multi regime models, right? Like that, if you just observe, right? These are the different models you are having, right? What they are showing, these fundamental diagrams are showing graphical relation between which one? Graphical relation between which one, this q, k and v, you can see if you just observe it like that. Yes, now so that is your 333 and now 334. So what is that you can say, if you consider this green shield model, what is it? Green shield model, you can say green shield model or linear model, right? So this is the mostly used model. If nothing is mentioned, which model we have to consider by default? This green shield model only we have to consider. What is the v? You can say v is nothing but your vf into 1 minus k by this kj. So what is the vf? Vf is nothing but your free flow speed, kj is nothing but your jump density, and q equal to kv. Now tell me, what is that? Q maximum, right? What is the Q maximum expression? You can say Q maximum is nothing but your kj by 2 into this vf by 2, right? So there are many questions on this calculation, you can say, right? So what is that k value? It is this q equal to q maximum, right? It is q equal to q maximum, right? What is the k value? K is nothing but your kj by 2, and what is the speed? You can say that speed is nothing but your vf by 2, if you just observe it like that. This is your green shield model or linear model, right? By default we have to use this only. Now what is the next one? Underwood model or exponential model. Underwood model, or what is another model, you can say exponential model, right? Underwood model or this exponential model, if you just observe, right? Whenever this Underwood model or exponential model is given, right, what is it? You can say v equal to vf into that e power minus k by this kj, is not? And what is that? You can say that q maximum, right? What is the q maximum? You can say q maximum is nothing but your kj into that vf by e. What is the meaning of this kj into that vf by e? So at this q equal to q maximum, what is that k? You can say jump density, and what is that v? You can say, if you just observe that vf by e, right? This is your Underwood or exponential model, you can say, right? Like that, is not? Now 336, right? What is that? Greenberg or logarithmic model, right? One fellow has given linear relation, one fellow has given exponential relation. Therefore, other fellow has given which one? This is a Greenberg model logarithmic relation, right? Greenberg or logarithmic model. What is this Greenberg fellow has given? If you just observe that v equal to vf into what is it? You can say that log kj by k to the base e, right? You have to be careful, right? Then what is the q maximum here? There is a question from this model in 2012. What is the q maximum? Kj by e into that vf. So now tell me, at this q equal to this q maximum, right? At this q equal to q maximum, right? What is the k? You can say density is nothing but your kj by a, and what is the speed v? You can say speed v is nothing but your vf by e, if you just observe like that. It's not like that you are having, right? These are the three models, right? This is your first model, right? This is your this is your green shield model first model, you can say first model, you can say this is your second model Underwood model, and this is your third model Greenberg model you are having, right? Like that. It's not? So now green shield model only, you have to remember this fundamental diagram, right? You have to remember the fundamental diagram for this green shield model only, right? What is that? You can say don't remember for anything else. This is your speed, this is your density. What is that model you are having? This is the model you are having, okay? This is your kj, and this is your vf, and this is your 0. And what is another relation you are having? If you just observe, this is one relation. This is your q versus k. Whenever it is your q versus k, it is like this, right? So this is your q maximum corresponding to this q maximum. What is the k? You can say this is your kj, and this is your kj by 2. That's not like that. And what is another relation you are having? If you just observe between them, so this is the another relation you are having, right? This is your v versus this q, right? V versus this q. This is the relation we are having finally. Now what is this one? You can say this is your Q maximum, na? This is your Q maximum, and what is this? This is your Vf by 2, right? Fundamental diagram. We are using by default this one only in our designs, you can say, right, like that, yes, na? And this is your pipes generalized model. Generalized model of pipe. This fellow has given this equation. So these are the things, you can say, relations. Northwestern model. This is your northwestern model equation. So like that. Other models like a Drake model is there. This is the Drake model expression. This is your Drew model expression, right? Like that. We'll be having all other expression, right? And multi-regime models, right? What is the meaning of this multi-regime models? More than single variation are there, right? First one is your Smulders model. Here one variation, here another variation, right? This is your between this speed versus this K, and this is your which one? This Q flow versus this density. This is your which one? This speed versus this flow, you can say, right, like that. Yes, na? Smulders model and DRAM's model, and also D'Agonzo model, right? There is a question from this D'Agonzo model. If you just read, what is the first relation? It is your QK relation. What is the second relation? It is your UQ or VQ relation. And what is the third triangular model? Means this model, right? This is your QK relation, like that. So this is your Eddy's model. It is a combination of which one? This Underwood model as well as this Greenberg model. And it is where Underwood also has given two regime model, you can say, right? Dick also has given two regime model, right? Like that. These are all the relations you'll be having, right? So for different models, green shield, triangular, truncated triangular, Smulders, Drake, inverse lambda, view. These are all the models of this fundamental diagrams of different models you are getting if you just have read of it. Yes, now, right? Okay. So is it clear, everyone? So now, what is it you can say? That capacity of rotary. What is the capacity of rotary if you just observe? The capacity of this rotary QR will be equal to how much, you can say? If you just observe, that is your 280 into W, right? 280 into W into that 1 plus E by W into 1 minus P by 3 divided by which one? This 1 plus W by L, right? So what is that E, you can say? Average of this entry width and exit width, no? E equal to average of this entry and exit widths. And what is that W? Width of this rotary roadway. What is that? You can take it E plus 3.5. L is nothing but your length of this weaving section. Then what is that P? Proportion of this crossing traffic or weaving traffic, right? B plus C by A plus B plus C plus D, right? What is it you can say? It is nothing but your crossing traffic. It is nothing but your crossing traffic divided by which one? This is total traffic, you can say, right? Crossing traffic divided by this total traffic, right? This is your capacity of which one? This rotary, you can say, if you just have it like that. Yes, na? So these are all the formulas, you can say. So with this we'll be closing it. Okay. So 335, 336. Let us say this is 337. You can give it. Okay. So with this we'll be closing this, and I'll be sharing this PDF in the groups, right? Just to check it. And what is it? Password I'll be using. I'll be using password as all formula. Okay, A capital and F capital, right? This is a password I'll be using. Thank you all of you. Have a good day, right?